Hi students, it's Miss Ayala. Today I'm going to teach you how to model division with regrouping using partial quotients. Meaning I'm going to break apart my problem into smaller parts to figure out my quotient. Let me show you how. Let's start with this first problem. It says, Jacob has 51 apples. He needs to divide the apples into 3 equal groups. How many apples are there in each group? Okay, we start with our mind movie. We read it one time. We have to read it a second time, and that's when we create the picture in our mind. So, my mind movie, I see a boy named Jacob, and what does he have? That's right, he has apples. How many apples? Good, 51. He needs to divide them into how many groups? Excellent. Yes, 3 groups. And how do we know it's 3 groups? Absolutely. It shows it in our problem. So let's see. Let me go through it. Jacob has 51 apples. He needs to divide them into 3 equal groups. How many apples are there in each group? Okay, so I know the total number of apples. I know how many groups. I'm trying to figure out what? What is my unknown? Good. My unknown is the number in each group. Now remember, I write, you write, so you should be writing everything down. Let's put this in a word problem structure format so I know and I can label my unknowns. Then we're going to solve it. So, do I know my total? Good, excellent. What's my total? 51. That's right, he has 51 apples. So should my answer be greater than 51? No, absolutely not. No. Especially with division, your answers are going to be smaller than the number you started with. Because when you divide and you make groups, or you find the number in each group. So it'll always be smaller than the total that you start with. So to set up my word problem structure, I'm going to draw my total line, and I know my total. So I'm going to write 51 apples up here at the top, 51 apples, and I also know my groups. How many groups? That's right, 3. So I can draw 3 boxes. Now, what number do I put inside the boxes? That's right. I don't know what number goes inside the boxes. That is my unknown. So I will be putting question marks inside all 3 of those boxes because the number in each group is unknown. That's what I'm searching for. So now I'm going to take what I know and I'm going to build it into my model of division. So in my model, I know that I have 51 apples. So I'm going to show that as 5 tens to represent the 50. And then I'm going to have 1 1 to represent the 1 for 51. Now, how many groups do I have? That's right, I have 3. So I know that I can create 3 groups. My job is to figure out what goes in each. So I'm going to do it equally as possible. I'm going to take one of the 10s and I'm going to move it. So this 10, I'm going to put into this group. This 10, I will put into this group. This 10, I will put into this group. Now, do I have enough 10s to do the same thing again? No, I don't. What do I have left over? How much? Excellent. I have 21 left over. Okay, so I have to think to myself, well, I know I have 3 groups. I have 21 left over. So I have to think to myself, how am I going to split up that 21 to put an equal amount in each of the 3 boxes? Now this is where my multiples kick in, because in my brain, I know that I have 3 groups. So that means that I can skip count by 3 to figure out how many 3s are in the 21, because that's what I have left over. The 10 was easy because I had enough 10s to put 1 in each box. But 21, I can't put a 10 and a 10 and then throw this 1 down here. It's not going to work. I have to go back to my multiples, and I know I'm going to use 3 because they were 3 groups. So let's start with our multiples of 3. Let me hear them. Okay, excellent. You can stop there. All right, so now I'm looking at what I have left over, and we said we had 21. Now, can 3 go into 21? Yes, absolutely it can. Here it is right here. Look at that. 21. But we need to count and see how many. How many times did it go in? So let's count. That's 1, 2, 3, 4, 5, 6, 7 times. 7. So I can break 21 up into 7, 7, and 7. Because 3 groups of 7 equals 21. So I can put 7 into the 3 groups. So students, how much, or how many apples, I should say, are in each group? That's right. There are 17 apples in each group because we have 10 and 7. What is 10 plus 7? Good, 17. So I can go back to my original word problem structure of equal groups, and instead of those question marks, what can I write in there? Excellent. Now I can write 17 in each of those boxes. So how many apples are there in each group? 17 apples in each group. Good job. Now let's try it with just a division problem. So if you have 92 divided by 2, and we're looking for the quotient, we can still model it with the division showing the regrouping. So what is my total for this problem? That's right, it's 92. So again, I can draw my word problem structure. 92 is my total. How many groups do I have? Excellent, 2 groups, meaning I have 2 boxes. What do I put inside of each box? Good, yes, question mark, because that's my unknown. I don't know how many are in each group. I have 92 and 2 groups. So let's model it. I'm going to take this 92 and let's break it up into tens. How many tens are in 92? Good, 90. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, let's write 10 inside of each. I write, you write. And I have to show 1 and 1 to equal the 2. So there's my 92. I have 2 groups. So let me draw my groups. 1, 2. I have to put an equal number in each group. So let's start doing that. Let's grab the 10s first. So this 10 in here. This one over here. This one here. This one here. And so on. Let's keep going. Okay, I'm going to stop there. I've gone through 6 of the 10, so that's 60. I want to look and see, do I have enough to put another 10 in each box? Yes, I do. Good. Okay, so 10 and 10. Now, do I have enough to put another 10? No, I don't. So let's look at what we have left. How much do we have left? Excellent, 12. Now, again, this is where our multiples kick in. Go back and see how many groups you had. So what am I going to be skip counting by? Excellent, by 2. So let me hear your 2s. Okay, we'll stop there. What is the number that we were looking for? That's right, 12. So it's right here. I need to see how many times 2 went into 12. So let's count. 1, 2, 3, 4, 5, 6. Excellent, 6. So how much do I put in each of my groups? That's right, 6 and 6. So what is my quotient? How would I find it? I modeled it. What is it? What is my quotient? Excellent job. Yes, I would have to add all of the numbers inside of one of my groups. So 10, 20, 30, 40, 40 plus 6 equals 46. My quotient is 46. Now let's show what that looks like using the algorithm. So if I had 92, again, my total, that is my dividend because it's inside my division. My dividend is 92. My divisor is 2. So my job, and what I did modeling, I saw exactly how many 10s did I break apart first. How many 10s was I able to put into each group? Let's count all of our 10s. Let's see what we did. We did 1, 2, 3, 4, 5, 6, 7, 8. And how much is 8 10s? What's the value? Excellent, 80. So I was able to take 80 10s. Now I have to show what was in each group. I have to put that in the quotient. So I know in my division that I'm going to be subtracting, but I have to show on the top in the quotient area how many 10s I took to make the 80. Well, in each group, how many 10s did I have? That's right, 4. So 4 will go above the 9 to show the 80. Now, this is not a 4. We're looking at it as 40 because it's in the tens place of this quotient. So think in your head, 40 times 2 is 80. So now our next step in the division process is to subtract. So let's subtract. 2 minus 0. Good, 2. 9 minus 8. Good, 1. So what is our new dividend? That's right, it's 12. Now remember when we were modeling, what did we have left over? Yes, the 12. So now my new dividend is 12, and we realize when we skip counted, how many times did the 2 go into the 12? Yes, that's right, 6 times, because when we skip counted, 1, 2, 3, 4, 5, 6. 6 times. So I can put the 6 up on top of this 2 to show 6 times 2 equals 12. Then my next step is to subtract. 12 minus 12 is 0. My quotient is 46. Just like my model. Each of my groups contained 46. So now I can go back to my original word problem structure, and instead of those question marks, what can I put inside of each box? That's right, the number 46. And how can I prove it? How can I make sure that 46 and 46 equals 92. What could I do? So I want to prove this. What can I do with the two 46s? That's right. I can do 46 times 2, or I can do 46 plus 46. But since we're in 4th grade, I want to multiply. So 46 times 2, let's do that. What is 6 times 2? Good, 12, but I have to regroup that. So what goes where? Good, the 2 in the 1s and the 1 up in the 10s. All right, so now I multiply 2 times 4. What is 2 times 4? Good, 8, and then add the 1 on top. 9. 92. Is that what we started with? Yes, absolutely it was. So we just proved our answer. We double-checked our division problem with multiplication. Now, Miss Ayala wants to explain why we call this type of division partial quotients. Well, I broke apart the original dividend into partial quotients because I pulled apart the number 92 and I took 80. And then I pulled it yet again. So at first, see, here was my 80, or all those 10s. Then I pulled apart the 12. What is 80 plus 12? That's right, 92. So showing that I can pull 10s and then I can use my multiples to figure out my next partial quotient is how I divided to find my answer. Let's try another one. Let's say we have 54 divided by 3. Well, automatically, I know that I'm going to use my 54 and I'm going to break it apart. Now, I have to be certain that I break it apart the correct way, knowing that I'm going to be skip counting by what? That's right, my 3s. So let's go ahead and write those out first. Let's write out our 3s. Let me hear you. Okay, let's stop there. Now, as I'm pulling this 54, I'm going to break it apart to make it smaller. So let's grab some 10s. Look at your multiples of 3 and tell me what 10 do you hit? What multiple of 10 do you hit? Excellent, the 30. So I can break 54 up into 30 and what other number? What is 54 minus 30? Well, let's work it out. 54 minus 30. 4 minus 0? Good, 4. And 5 minus 3? 2. 24. Look at your multiples. So when I broke 54 into 30 and 24, does 3 go into 24? Yes, it absolutely does. Look, it's right there. Okay, so let's show our work. Let's rewrite this. 54 divided by 3. Well, we knew that we could take 30 out of 54. Now, how many times did 3 go into the 30? If I was counting, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. Now, I can put that 1 above the 5 because it's in the tens place. It represents the 10. So I can put the 1, but we're thinking 10. What is 1 times 3? Good, 30. Now, what do I do with these two numbers? That's right, subtract. 4 minus 0? 4. 5 minus 3? Good, 2. So now, take a look. Isn't that the same number we had over here? Excellent. Yes, look. So now I have to figure out how many times 3 goes into 24. And since I already used my multiples of 3 and I skip counted, I see automatically there's the 24 circled. But I have to figure out how many times that is. So let's go back and count. 1, 2, 3, 4, 5, 6, 7. How many times? Yes, 8 times. 8. So the 8, where does the 8 go? That's right. 8 becomes part of my quotient. 8. 8 times 3 is 24. What do I do with those two 24s? That's right, I subtract it. And 24 minus 24 is? Good, 0. So my answer, my quotient, 54 divided by 3 is 18. Good job. Okay, guys, now it's your turn to try it on your own. So go have some math fun.